Hello. For everyone wanting to escape the hustle and bustle of the city and embark on a journey to new horizons, we have great news. One day, you might just find yourself on the moon. Let's take a look behind the scenes of this exciting project together. Two innovative companies, Icon and Astroport, are gearing up to revolutionize the world of space engineering. But how will construction on the moon work? Here's the answer. Icon and Astroport are planning significant investments for the construction process on the moon. Icon has taken a major step towards realizing its vision of building on the lunar surface with a $57 million investment from NASA. This investment supports Icon's projects to produce concrete and construct buildings on the moon's surface using 3D printing technology. The company aims to produce sustainable construction materials by using lunar soil, known as regolith, which is abundant on the moon's surface. This method will significantly reduce the need to transport materials from Earth, thereby lowering costs. Astroport, on the other hand, is planning a $45 million investment for its Lunatron project. This project will involve producing lunar bricks from regolith, which will be used to construct landing pads and other structures on the moon. The company will also employ a series of specialized robots. These robots will handle tasks such as collecting, processing, and converting the regolith into bricks. These robots, capable of autonomous operation, will perform their tasks without human intervention, allowing construction processes on the lunar surface to be faster and more efficient. Icon and Astroport will collaborate to successfully manage construction processes on the moon. This partnership will combine each company's areas of expertise to develop more comprehensive and effective solutions. Icon will bring its knowledge and experience in 3D printing technology and concrete production, while Astroport will contribute its expertise in brick production, from regolith and robotic technologies to these projects. Icon and Astroport will support each other's projects by sharing their advanced technologies. Icon's 3D printing technology and Astroport's robotic systems will be used in a complementary manner in the construction processes on the lunar surface. Both companies will pool their resources for construction materials and equipment to be used on the moon. This will enable projects to be carried out more efficiently and reduce costs. Icon and Astroport will conduct joint research and development projects to develop sustainable construction techniques on the lunar surface. These projects will focus on the more efficient use of regolith, the development of durable building materials, and the optimization of robotic systems. As part of their collaboration, Icon and Astroport will conduct field tests and trials under conditions similar to those on the lunar surface. These tests are critical for evaluating the real-world performance of both companies' technologies and making necessary improvements. Icon and Astroport will provide logistical and operational support for construction projects on the lunar surface. This will include important aspects such as the transportation of materials and equipment, site preparation, and the coordination of construction processes. So, is living on the moon possible? The answer to this question dates back to the beginnings of humanity's interest in the moon. The possibility of living on the moon has fascinated scientists and dreamers for centuries. The first scientific observations of the moon's surface began in the 17th century with Galileo Galilei's telescopic examinations. Galileo discovered mountains and craters on the moon's surface, suggesting that the moon had features similar to those of Earth. However, more concrete ideas about the possibility of living on the moon began to emerge in the mid-20th century. In the 1950s and 1960s, with the acceleration of the space race, scientists began to discuss whether permanent human presence on the moon would be possible. The competition between the Soviet Union and the United States further fueled these discussions. In 1961, when U.S. President John F. Kennedy announced the goal of sending humans to the moon, studies on the possibility of living on the moon gained momentum. The Apollo 11 mission in 1969, with Neil Armstrong and Buzz Aldrin setting foot on the moon, provided significant information about the possibility of living on the moon. Data collected during this mission offered in-depth insights into the conditions and structure of the moon's surface. Comprehensive studies on the possibility of living on the moon followed the Apollo program in the 1970s. Samples brought back from the moon's surface and the data obtained were used to explore the challenges and potential solutions for permanent habitation on the moon. It was known that the moon had no atmosphere and its surface was exposed to radiation. Despite these challenges, scientists determined that structures built on the moon would need to withstand these conditions. In the 21st century, projects for living and building on the moon have become more tangible. Companies like Icon and Astroport are developing advanced technologies to bring these visionary projects to life. Projects for living and building on the moon are becoming possible, not just in science fiction films, but in real life. These innovative projects will play a critical role in establishing the necessary infrastructure for permanent human settlements on the moon and larger-scale space missions. First, let's talk about Icon, a pioneer in space construction projects. This innovative company has taken a significant step closer to realizing its vision of building on the lunar surface with a major investment from NASA. Icon is known for developing groundbreaking technologies in space construction. Icon's most notable feature is its use of 3D printing technology in construction processes. However, this is far beyond the 3D printers we are familiar with. Icon plans to use these printers to produce concrete using lunar soil, known as regolith, which is abundant on the moon's surface. Regolith is a material composed of fine-grained soil and rock particles on the moon's surface. This material is abundant on the lunar surface and contains various minerals such as silicate, iron oxide, and aluminum oxide. Regolith has been transformed into fine-grained material over time due to the impact of meteoroids and solar winds on the moon's surface. Icon plans to use this local material to produce sustainable construction materials. The 3D printer Icon will use is called Vulcan. Vulcan is an advanced printer capable of constructing high-performance and durable structures. This printer is specifically designed to withstand the harsh environmental conditions of the moon, such as low gravity and extreme temperature fluctuations. Vulcan will create concrete structures layer by layer using raw materials derived from regolith, utilizing robotic arms and precise nozzles. This innovative method offers a sustainable way to produce construction materials using local resources on the moon. This approach significantly reduces the need to transport materials from Earth, thereby lowering costs. The company aims to develop modular and expandable designs for these structures. Thus, as needed, structures can be expanded to accommodate more astronauts or equipment. Icon's ultimate goal is to provide all the necessary infrastructure for long-term human presence on the moon. This could be a critical step for future colonies to be established on the moon. Icon's visionary projects are seen as a promising step not only in the fields of space research and engineering, but also for the future of humanity in space. If these projects are successful, it will be possible to establish the necessary infrastructure for permanent human settlements on the moon and larger-scale space missions. Vulcan is designed to withstand the harsh environmental conditions of the moon, such as low gravity and extreme temperature fluctuations. On the lunar surface, temperatures can reach up to 127 during the day and drop to 173 at night. These extreme temperature differences pose a significant challenge in terms of the durability of construction materials and equipment. Vulcan is made from materials resistant to these temperature changes and is designed to withstand thermal expansion and contraction effects. Vulcan also features a specially designed infrastructure to operate stably and efficiently in the low-gravity conditions of the moon. The moon's gravity is only 1/6 that of Earth's, so the behavior of materials and equipment used during construction will also be different. Vulcan is optimized to adapt to these low-gravity conditions, allowing it to construct durable structures without compromising structural integrity. Vulcan's technology is based on converting raw materials derived from regolith into concrete structures layer by layer through robotic arms and precise nozzles. This printer offers great flexibility in the construction process. Its ability to build modular structures means that existing structures can be expanded or new sections can be added as needed in the future. Vulcan's automation systems are capable of remote control and autonomous operation. This feature allows construction processes to continue on the lunar surface without the need for human intervention. Additionally, the printer's structural design protects it against dust accumulation and other adverse environmental factors, providing long-term and uninterrupted operational performance. ICON's projects include the construction of shelters, research centers, and other infrastructure elements on the lunar surface. The company's goal is to provide all the necessary infrastructure for long-term human presence on the moon. Moreover, ICON's developed technology is not limited to the moon and can be used on other planets such as Mars. ICON and Astroport's visionary projects are seen as a promising step not only in the fields of space research and engineering, but also for the future of humanity in space. ICON began its collaboration with NASA in 2018. This collaboration was initiated to develop sustainable structures that could be built on the surfaces of the Moon and Mars. In the same year, ICON completed the Vulcan Eye, the first 3D printed house on Earth. This house demonstrated the potential of the printer in terms of durability and efficiency. In 2020, ICON partnered with NASA's Johnson Space Center on the Mars Dune Alpha project. This initiative aimed to test the technologies required for constructing habitable structures on Mars. As part of the project, a habitat was built using a 3D printer in a Mars-like environment. This habitat was designed to simulate the challenges astronauts might face on long-term missions and to find solutions to these challenges. Moreover, ICON's developed technology is not limited to the Moon and can be used on other planets, such as Mars. ICON and Astroport's visionary projects are seen as a promising step not only in the fields of space research and engineering, but also for the future of humanity in space. 2021 marked significant advancements in ICON's space construction technologies. The company announced Project Olympus, an initiative aimed at developing all the necessary technologies for building on the Moon. That same year, ICON joined NASA's Lunar Surface Innovation Initiative program, supporting the goal of creating sustainable habitats on the lunar surface. This project focused on the construction materials and techniques needed for building on the Moon. In 2022, ICON received additional funding from NASA to further develop lunar construction technologies. The company conducted a series of tests to produce construction materials using regolith on the Moon's surface. These tests, conducted in conditions similar to the lunar environment, provided valuable data on how ICON's technology would perform in the real world. 2023 was a milestone year for ICON. The company successfully constructed the first prototype structures using regolith in conditions similar to those on the Moon. These structures were designed to withstand the extreme temperature fluctuations and low gravity of the lunar surface. The prototype structures laid the foundation for larger buildings to be constructed on the Moon and demonstrated the effectiveness of the 3D printing technology used in the process. As of 2024, ICON continues to work on improved versions of its Vulcan 3D printer. Future plans include initiating a fully autonomous construction process on the Moon. The company aims to build permanent habitats, research centers, and landing pads on the lunar surface. Another exciting project comes from Astroport. With their Lunatron project, Astroport aims to revolutionize lunar construction processes. The project involves producing lunar bricks from regolith, a material abundant on the Moon's surface, composed of fine soil and rock particles. These bricks will be used for building landing pads and other structures on the Moon. Astroport also plans to use a series of specialized robots for this process. These robots will handle tasks such as collecting, processing, and transforming regolith into bricks. Thanks to their autonomous capabilities, these robots will perform their duties without requiring human intervention. Astroport's work presents a significant innovation in the fields of space engineering and construction technology. The company has been working on the concept of building on the Moon's surface for many years and has gone through various stages to achieve this goal. Founded in 2019, Astroport focused immediately on researching construction materials and robotic technologies for lunar use. 2021 saw further advancements in Astroport's robotic systems. The company produced more advanced robots with autonomous capabilities, able to perform their tasks on the lunar surface without human intervention. That year, Astroport also collaborated with NASA, receiving technical and logistical support for lunar construction projects. In 2022, Astroport made significant progress in the production of bricks from regolith. The company conducted successful tests showing that regolith could be turned into strong, durable bricks through high-temperature processing. These tests demonstrated the brick's durability under the moon's low gravity and high radiation conditions. In 2023, Astroport conducted more extensive trials on Earth under lunar-like conditions. These trials tested the robot's autonomous capabilities and the brick production process in real-world scenarios. The trials yielded successful results, providing crucial data on the feasibility of construction projects on the lunar surface. As of 2024, Astroport is one step closer to launching the Lunatron project. The company plans to begin real construction projects on the moon, initially focusing on building landing pads and small structures. These structures will lay the groundwork for larger and more permanent settlements in the future. Astroport also plans to participate in various space missions to test their robots and construction techniques on the moon. Astroport's projects offer not only increased safety, but also economic advantages. Reducing the need to transport materials from Earth will significantly lower costs, allowing space missions to utilize their budgets more efficiently. This will enable more numerous and comprehensive space missions in the future. The Lunatron project by Astroport will play a critical role in creating the infrastructure necessary for sustainable and long-term human presence on the moon. The ability to construct buildings using local materials on the lunar surface is a major step towards future colonization projects. Just imagine, producing lunar bricks on the moon could be a revolutionary step. This innovative approach will eliminate the need to transport construction materials from Earth, providing a significant logistical advantage. Bricks produced on the moon will drastically reduce construction project costs and make a sustainable building process possible. Lunar bricks will be used for building landing pads. These pads are crucial structures that ensure the safe landing of spacecraft on the moon's surface. Constructed from strong and durable bricks, these pads will minimize potential hazards during landing. This will make lunar landings safer and reduce mission risks. It seems that seeing construction on the moon is becoming a reality, not just a scene from science fiction movies. The efforts of innovative companies like Icon and Astroport are paving the way for space construction to become a reality in the coming years. Construction projects on the moon represent a significant leap forward for humanity's space exploration and colonization efforts. Stay tuned to our channel to keep up with these developments. By following us, you can stay informed about the latest advancements in space construction projects and gain exciting insights into the future of space exploration. Don't forget to like our video to show your interest in our content on space exploration and construction. We can't wait to see how construction in space will evolve. See you in the next video. Goodbye.